Good morning. Let's get ready for working on some math and finding least common multiple and greatest common factor. If you look at the board, the whiteboard, not this Promethean screen, look at the whiteboard, and there are the anchor charts for finding greatest common factor and least common multiple. Make sure you use those. If you are not sure about one of the strategies that you need to be using, those are there as a reference. And you may also use your math notebook. If I say talk with your partner, then you are having a conversation. Other than that, you should not be talking, particularly if Mrs. Nash or I am talking. Your mouth is closed. Remember, safe, respectful, and responsible. So Mrs. Nash is going to pass out the worksheets that you're going to be using as we work through these different examples of finding greatest common factor and least common multiple. When you're looking at the examples, if you're thinking, oh, I get this, and you're rushing ahead, you may end up making a mistake. So please don't do that. Okay, follow along with what we're doing. There's going to be times I'm going to ask you to discuss your steps and strategies together. And then you, by all means, you should be talking. Everyone should have their pencil out now. And you should have that on your desk. No highlighters, no markers, no anything else for working with math other than a pencil. So take that out, put it on your desk, and while Mrs. Nash is passing out the papers, I'm going to go over what we're doing, why we're doing it, and how you're going to know that you're successful. So taking a look at what we are learning. Well, today you're going to be using the strategies for finding the greatest common factor and least common multiple so we can know how to use each one. Why we are learning this? The more we work with these strategies and practice how to use them, the better we will be at working with fractions. Next week, we're going to move into starting to, actually before we start dividing fractions, we're going to work with mixed numbers and changing a mixed number to an improper fraction and converting a fraction to a decimal and then to a percent. So we have some interesting work ahead of us. And so the strategies of least common multiple and greatest common factor are going to be useful when we're doing this. How we will know we have learned this, we will be able to explain the process for finding the greatest common factor and the least common multiple and use the correct method to find either the GCF or the LCM. So now you should have all of your papers distributed and a pencil in your hand and ready to go. So we're going to first start with the paper that has greatest common factor. So take a look at your 2 pages. Get the one that says Extra Practice, Unit 1, Lessons 15 through 16, Greatest Common Factor. Check your partner, make sure they've got the same side showing, because this is what we're going to start working on. And you are going to use either the ladder or the factor tree. For the first 2, I'm going to use the ladder method. For the next 2 examples, 3 and 4, I'll use a factor tree and I'll go back and forth. If you truly, truly, truly love a factor tree and you want to use that, even though I'm using the ladder method, you may do so. Okay? So get ready and we're going to begin. So I need to find the greatest common factor of 14 and 42. So my first step is to line my numbers up and to draw the ladder. So there you go. Now, my next step is to pull out the smallest prime number. Smallest prime number is going to be 2. 2 times 7 is 14. and 2 times 21 is 42. So I've pulled out a 2. Now I'm looking at 7 and 21. And I definitely know 2 is not going to go in. 5 isn't going to go in. So the next prime number is 7. And 7 goes into 7 one time. 7 goes into 21 3 times. Now I'm looking for the greatest common factor, the largest factor common to both. So our strategy says I'm going to circle the 7 and the 2. And I'm going to multiply 7 times 2, and that's 14. So my greatest common factor for 14 and 42 is 14. Now I'm going to set up the second one, and then I'm going to have you work individually. You're not going to be sharing on this very next one, working individually, and then you'll check back in and see if your answer matches mine. So again, greatest common factor, 12 and 16. So I'm going to write my numbers on a line, and I'm going to draw my ladder. Smallest prime number for 12 and 16 is going to be 2. So Mrs. Nash is going to pause the video here, and she's going to give you about 1 minute, 30 seconds to finish the rest of this. And then she's going to start the video again, and you're going to compare your answer to what I have for mine here. Okay? So pause the video here, working individually and quietly, and go. Okay, now we're back, and let's see how you did. 2 times 6 is 12. 2 times 8 is 16. I'm going to draw my next ladder, and I can pull out another 2. 2 times 3 is 6, and 2 times 4 is 8. And I'm looking at 3 and 4, and there is no other prime number that can go in. So I'm going to circle my prime numbers on the left. I'm going to multiply 2 times 2, and that equals 4. So my greatest common factor is 4. Okay, good job. And I have no doubt you all got that one correct. Now, we're going to take a look at the next 2. And remember I said these I'm going to do as a factor tree. So I'm looking at the greatest common factor of 40 and 30. So I'm going to set up 40. I'm going to set up 30, where with the ladder method, you can pull out prime factors for both numbers at the same time. With the factor tree, we need to do them individually. So I'm going to set up my branching system. And again, I'm going to start with the smallest prime number. 2 times 20 is 40. I'm going to circle 2. I'm going to pull out another prime number. 2 times 10 is 20. 2 is prime. I'm going to circle that. Again, I'm going to pull out smallest prime number. 2 times 5. 2 is prime, 5 is prime. Remember, you circle your prime numbers. That lets you know which numbers you still need to factor out more completely. If it doesn't have a circle around it, because it's not prime, you can still factor it out more. So now I'm going to come to 30. Smallest prime number, still 2. 2 times 15. Circle the 2 because it's prime. 15, however, is not. Smallest prime number is 3. 3 times 5 is 15. Going to circle the 3, going to circle the 5. Now, I'm going to line up all of my prime factors, and I'm going to look for those prime factors that are shared by both numbers. So 40 is 2 times 2 times 2 times 5. And 30 is 2 times 3 times 5. Well, I can see that they share a 2 and they share a 5. And this is going to count as just 1, 2. I'm not multiplying 2 times 2. So I'm going to have 2 times 5, because those are the two factors that 40 and 30 share. 2 times 5 is 10, and 10 is my greatest common factor. Okay? Now, just as I said, if you prefer the factor tree rather than the ladder method, you could use either one. If you prefer the ladder method and I'm doing the factor tree, it's fine for you to go ahead and use the ladder method and continue. Okay? So now I'm going to set these two up, 20 and 28, and I'm going to set up the branching structure here, and Mrs. Nash is going to pause the video here for, this might take a little bit longer, 2 minutes. And you're going to complete the rest of the work and then check back in and see how you did. So pause the video here. Again, working individually. You are not sitting there and chatting and talking. Individual work. And get ready, 2 minutes, and go. Okay, now let's check and see how you did. Again, I'm going to start with my smallest prime number. And I'm going to pull out a 2, and 2 times 10 is 20. 2 is prime. So I'm going to look at 10, and that's 2 times 5 is 10. 2 is prime, 5 is prime. 28, 2 is the smallest prime number I can pull out. 2 times 14 is 28. That's prime. 14 is not. 14 is 2 times 7. However, 2 is prime and 7 is also prime. So now I'm going to line my numbers back up. And for the 20, I have a 2 times 2 times 5. For the 28, I have a 2 times 2 times 7. Now I'm going to look for the prime numbers that 20 and 28 share, and I'm going to circle those. So there's a 2. There's another 2. This has a 5, this has a 7. Those are not common. I'm going to leave those alone. And I'm going to multiply 2 times 2, and that equals 4. So my greatest common factor for 20 and 28 is 4. Now, 5 and 6. I'm going to have you now work with the person next to you. You can use either the factor tree or the ladder method, but keep in mind when I work these out here, I'm going to be using the ladder method. Your greatest common factor will still be the same. It doesn't make any difference if you've done it correctly. Your greatest common factor, whether you do the ladder method or the factor tree, is still going to be the same. Okay? So, Mrs. Nash is going to pause the video here. You're doing both 5 and 6. You need to set up whichever structure you want to use, the ladder method or the factor tree, pull them all out, find the greatest common factor, and you're going to have 4 minutes. You may talk with your partner, but at the end of 4 minutes, You need to have these two completed because you're turning in all of this paper. And if you do not have these done, I'm fairly certain you've been not as focused as you could be. Okay? So, pause the video here, 4 minutes, working on 5 and 6, using either method you want, and begin. Okay, so your 4 minutes are over. Let's take a look and see how you did. Again, I said I'm going to be using the ladder method. I actually find this to be more efficient than the factor tree, but that's my preference. It does not have to be yours. Either way, 2 is the smallest prime number. 2 times 6 is 12. 2 times 14 is 28. I'm going to draw another ladder, and I've got 2 again. 2 times 3 is 6. 2 times 7 is 14. And I have 2 times 2 equals 4. And so my greatest common factor is 4. Taking a look at 6, I'm looking for the greatest common factor of 36 and 54. So I'm going to set up my structure for this. And smallest prime number is a 2. 2 times 18 is 36. And 2 times 27 is 54. I'm going to add another ladder. Now I'm looking at 18 and 27. Well, 2 can go into 18, but 2 cannot go into 27. However, 3 can go into both. 3 times 6 is 18, and 3 times 9 is 27. I can add another ladder, and I can pull out another 3. 3 times 2 is 6. 3 times 3 is 9. Well, I'm done pulling out prime factors. There's nothing else there. So I'm going to circle these numbers, and I'm going to multiply 2 times 3 times 3. And 2 times 3 is 6. 6 times 3 is 18. And your greatest common factor of 36 and 54 is 18. And you're going to do the same thing with 7 and 8. You're going to have 2 minutes. You're going to find the greatest common factor. You can use either the ladder method or the factor tree. But again, at the end of 4 minutes, you need to have all of this done. So don't spend your time just chatting. Stay focused. And if you want to work with the person next to you and talk about the process, that's fine. You can check your work, make sure your answers match, come to consensus, and in 4 minutes, we're going to check and see how you did. Get ready, pause the video, and go. Okay, so now 21 and 42. Smallest prime number. And I'm looking at 42. I want to know if 3, because I'm thinking 3 is going to work, can go into 42. And the way you can check and see if a number is divisible by 3 is add these two numbers together. And if the sum is divisible by 3, this number is divisible by 3. 4 plus 2 is 6. 3 goes into 6. So 3 it is. 3 times 7 is 21. And 3 times 14 is 42. I'm going to add my next ladder. And 7 times 1 is 7. 7 times 2 is 14. Circle the numbers on the left. I'm going to multiply 3 times 7. And 3 times 7 is 21. And my greatest common factor, for 21 and 42 is 21. Now I'm looking at 64 and 32. I'm going to set up my structure. And since 64 and 32 are both even numbers, I know my smallest prime number is 2. And this is going to be 2 times 32 is 64, and 2 times 16 is 32. I can still use 2 as my smallest prime number, and 2 times 16 is 32, and 2 times 8 is 16. I can still use 2. 2 times 8 is 16. 2 times 4 is 8. A lot of 2's in this one. I can pull out another 2. 2 times 4 is 8. 2 times 2 is 4. And I am so running out of room. Again, I can pull out another 2. 2 times 2 is 4, and 2 times 1, thank goodness because I had no more room, is 2. So I have all of my factors, and notice all of the factors are 2. 1, 2, 3, 4, 5. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Now, I'm going to look at combining these and see what I can do here. I'm going to look at these two. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. 16 times 2 is 32. My greatest common factor is 32. Okay, I could also do 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. But if you look and you can group, that's another way of being able to do that. So either way, your greatest common factor is 32. We are done with greatest common factor. We are now going to the next page, least common multiple. And I am going to be using the ladder method for this. This is the only method that I've shown you for being able to find least common multiple. And if you are really curious and you want to know, can I use the factor tree? Yeah, you can. And come in at lunchtime and I'll show you how to do it. Come in at lunchtime Monday or anytime from now on that you want to see how you can use the factor tree. And I'll show you what you do. So again, these first two we're going to do together. And you are following along with what I'm doing. So I've got 6. Oops. Let's get you out of there. And 6 and 21. Okay, so draw my ladder. 6 and 21. Well, smallest prime number is 3. 3 times 2 is 6. 3 times 7 is 21. Now, least common multiple. Remember what we do for the multiple is I'm going to circle the 3 and I'm going to circle these numbers here. We're looking for the L. These two circles here and here form an L for least common multiple. And I multiply 3 times 2 times 7. Well, 3 times 2 is 6. 6 times 7 is 42. And that is your least common multiple. The first multiple that 6 and 21 share is 42. Now we're finding the least common multiple of 4 and 14. Again, I set up my structure. Remember we said finding the greatest common factor using the ladder method and the least common multiple are very similar. The only difference is the numbers that you multiply after you pull out all of the prime factors. So I have 4 and 14. 2 is my smallest prime number. 2 times 2 is 4. 2 times 7 is 14. And I don't have any other numbers that I can pull out. So I'm going to circle the 2. I'm going to circle my numbers at the bottom or at the base. And I'm going to multiply 2 times 2 times 7. 2 times 2 is 4. 4 times 7 is 28. And the least common multiple for 4 and 14 is 28. Now, 3 and 4. I'm going to set up the structure. I'm going to get you started. And then you're going to finish. Let me set them up for both here. 13 and 26. I want you guys thinking about this one. 13 and 26. What can go into 13? Well, let's go back here. 7 and 21. Well, the only prime number that can go into 7 and 21 is 7. 7 goes into 7 one time. 7 goes into 21 3 times. I'm going to circle on the left side. I'm going to circle the numbers at the base, and I'm going to multiply 7 times 1 times 3. 7 times 1 is 7. 7 times 3. 21 is your least common multiple. 21 is the first multiple that 7 and 21 share. Now, 13 and 26, smallest prime number. Well, it's not going to be a 2. It's not going to be a 3. Can't be a 5. Can't be a 7. So, what prime number? Yeah, you're right, 13. 13 goes into 13 one time. 13 goes into 26 2 times. I'm going to circle. I'm going to circle. There's my L. And 13 times 1 times 2. And 13 times 1 is 13. 13 times 2 is 26. And that's your least common multiple. So the only difference in the ladder method from greatest common factor and least common multiple is with least common multiple, you multiply all of your numbers that you pulled out together. Greatest common factor, you only multiply your prime factors on the left side. Now, here we go. 5 and 6. You're going to have 4 minutes. You're going to set up your structure for both. You're going to pull out your prime factors until you can't pull out anymore. You're going to circle numbers on the left side, circle the base numbers, and multiply them all together. Okay? You may work with your partner, or if the 4 of you sitting in a group can work together without being silly and just making noise, then the 4 of you can work together. But come to consensus, check your answers, make sure that you are all in agreement. Pause the video here, 4 minutes, and begin. Okay, so let's check and see how you did. I've got 6 and 14. So I know I can use a 2. 2 times 3 is 6. 2 times 7 is 14. Get out of there. And there's no other number that I can pull out. So I'm going to multiply. I'm going to circle first. I'm going to multiply 2 times 3 times 7. Well, 2 times 3 is 6. 6 times 7 is 42. And 42 is the least common multiple for 6 and 14. Okay, I have no doubt that's exactly what you got for your answer. Now we're going to look at 10 and 12. And we're going to do the same thing. Set up the structure for the ladder method. And 2 is the smallest prime number. 2 times 5 is 10. 2 times 6 is 12. I can't pull out any of the prime numbers, so I'm going to circle these. 2 times 5 times 6. 2 times 5 is 10. 10 times 6 is 60. And 60 is your least common multiple. I have no doubt you got that one too. Good job. Now, we've got 2 word problems here. You are not going to have to draw the problem-solving strategy because you're probably getting close to the end of the period right about now. So we're going to take a look at the word problem. George goes to the gym every 4 days and runs on the beach every 6 days. If he does both today, he's going to the gym and running on the beach. How many days will pass before he goes to the gym and runs on the beach again on the same day? So every 4 days he goes to the gym. Every 6 days he runs on the beach. Today he did both. And we need to figure out how many days will pass before he's doing the same again. This should lead you to, I've got 2 different numbers, and I want to know what number is going to be common to both. I don't want a factor. I need something that's going to be larger. So I'm looking for least common multiple. And I'm going to pull out a 2. 2 times 2 is 4. 2 times 3 is 6. And I'm going to multiply 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So 12 is your least common multiple. On this day, he did both. In 12 more days, he's going to be doing both again. Okay, that's your least common multiple. Joni is running the hot dog stand at a carnival. Hot dogs come in packages of 12, and hot dog buns come in packages of 10. So you have more hot dogs than when you have buns, when you buy the packages of each. What is the least amount of hot dogs Joni has to sell so that she does not have any leftovers from any package? She doesn't want to have to give any of this food away or throw any of it away. So we need to find a number that's going to be common to both, but not a factor. We need a least common multiple. So I've got 12 and 10. Smallest prime number is going to be 2. You take it from here. You've got 2 minutes. Finish the rest of it and then check back in. Go. Okay, so 2 times 6 is 12. 2 times 5 is 10. 6 and 5, there's no other common factor that I can pull out or prime factor that I can pull out of those. So I'm going to multiply 2 times 6 times 5. 2 times 6 is 12. 12 times 5 is 60. And she has to be able to sell 60 hot dogs so that she does not have any hot dogs or buns left over. That's your least common multiple. Good job. Now, Make sure your name is on both papers. You're going to turn your papers in. This is your proof that you were working this period. And if I do not see all of the work that we did here on yours and only bits and pieces of it, I'm going to be pretty sure that you are not focused and working along with what we were all doing here. Okay? So you guys have a great weekend. I will see you on Monday. And remember, respectful and responsible behavior for the whole day. Have a great weekend, and I'll see you on Monday.